So, as always, your practice test looks identical to your test. Okay. The only difference tomorrow is you are going to need to know how to create a Venn diagram. And I will not list out what is in the set. So this will say something like integers 1 through 10. And then you will have to go through and write out what the integers are. Okay? You need to know what even numbers are. You need to know what odd numbers are. You need to know what prime numbers are. You need to know what factors are. So if I ask you for all the factors of 12, that's everything that multiplies to 12. So 1, 2, 3, 4, 6, and 12. Right? Because 1 times 12, 2 times 6, 3 times 4. Those are all factors. So you need to know that as well. And that's how all of your sets are going to be. So you have to write them out. Yes?
Do you need to know composite?
You do not need to know composite. But composite is pretty much everything except prime and except 1. Okay? Any other questions on that part? Okay. Madison, stop. So this first one, what is not in Z? So you're going to look at Z and you're going to look at your universal set and figure out what is not in Z. So 2, 4, 6, 7, 8, and 10 are not in Z. What is this symbol here? What's it? The union. So it's everything they're bringing together. You just don't have to write any numbers twice. So if I look at Y and Z, it includes everything that they both have. So 1, 2, 3, 4, 5, 6, 9, and 10. What is this symbol? Intersection. It is what they have in common. So looking at X and Y, what they have in common is 1, 2, 4, and 6. Okay. Okay. First thing you need to figure out before you do the intersection is what is not in Y. That's your first step. So what's not in Y? 3, 5, 7, 8, and 9. Now you can do the intersection with X. So what they have in common is 3 and 5. I had a lot of people ask me what the difference between number 3 and 5 was, and the answer is nothing. Okay, the intersection of X and Y is going to be the same as Y and X. So your answer here is 1, 2, 4, and 6.
Are you put that on the test to try and trick us?
No, I don't think so. There's not as many questions on the test. Okay. And then the last one, what is not in X is 7, 8, 9, and 10. Are there any questions on set theory? Yes. Correct. So 2, 3, 5, 7, and so on. So prime numbers, 2 is a prime number. 1 is neither prime nor composite. Yes.
How would you do something like X set minus Y? Like, how would you do that?
So this.
Yeah.
Okay. So 4x set minus y. You take x, which is 1, 2, 3, 4, 5, 6, and you delete everything that matches with y. So y has a 1, so I'm going to cancel it. Y has a 2, so I'm going to cancel it. Y has a 4, y has a 6. What's left over? 3 and 5. Okay? So it would be like subtracting. 1 minus 1 is 0. Like it goes away. 2 minus 2 is 0. It goes away. And then whatever you can't like match up stays. Okay? Anything else on set theory? All right. A deck of cards. We should at this point know what is in a deck of cards. So quick recap. There are 52 cards in a deck with 4 suits: hearts, diamonds, spades, and clubs. Each suit has 13 cards. Each suit has 3 face cards, Jack, Queen, and King. I think that's it. Each type of card, there are 4 of each type of card. So there are 4 twos, there are 4 aces, there are 4 kings. How many red cards are there? 26, because you have diamonds and hearts. How many black cards are there? 26, because you have clubs and spades. Okay, so the probability of pulling a heart, how many hearts are there? 13 hearts out of a total of 52. You have to reduce that, and that reduces to 1/4. What is the probability of pulling a king? How many kings are there? 4 out of 52. So that reduces to 1/13. What is the probability of pulling a king of hearts? There's only 1 king of hearts out of the total deck, which is 52. Now, number 10 confused some people. So, what is the probability of pulling a jack? Let's start there. How many jacks are there? 4. Okay, there are 4 jacks. Now, this part is where people got confused. If you know that it is a face card, so what it's saying is if the cards in your hand are only face cards, what's the probability of pulling a jack? How many face cards are in a deck? 12. Okay, you don't have a whole deck. You know that the cards you are choosing from are face cards, and there are only 12 face cards. So that final answer is 1/3. Okay? A jar contains pennies, nickels, dimes, and quarters. First of all, how many coins are in this jar? 100 and what?
18.
Oh, I heard like 4 different numbers. Okay, 118. Right? Add up all the coins. It is equally likely that any one of the coins will fall out when the jar is turned upside down. What is the probability that the coin will be a penny? How many pennies are there?
75.
So 75 out of 118. It doesn't reduce, so you're going to leave it just like that. How many quarters are there? 8 out of 118 reduces to 4/59. Not a penny. How'd you get 43?
Subtract 75, 118 minus.
So 118 minus the number of pennies, which is 75, leaves you with 43 coins out of 118. Or you can add up the other ones. Either way is fine, and that does not reduce. A dime or a nickel, there are 15 dimes. Or tells us to add. Nickels, there are 20. So 35 over 118, which does not reduce. Huh? Still good? What is the probability that you will choose a 2 or a 3? So how many 2s are there? 4 tells us to add. How many 3s are there?
4.
Okay. And we're choosing out of an entire deck. Whoops, that should say 8. What's the entire deck?
52.
Okay. And I know that reduces to 2/13. Okay, that's just the probability of a 2 or a 3. Are we okay? And tells us to multiply. We're going to pull a 5 without replacing the first card. So what's the probability of pulling a 5? 4 out of 51. Okay, there are 4 5s. You don't get that still? So here's what happened. You have a deck of cards, right? Hold on. Let me get out my deck of cards. I have 52 cards in this deck. The probability of pulling a 2 or a 3. So I pull out a card and hope that it's a 2 or a 3. It's not, but I'm not putting that card back in the deck. How many cards are now in my hand? Okay, now the probability of me pulling a 5 is obviously not very high. No, I'm not that good. Okay, so we're going to multiply across and we get 8 out of 663. That is a low probability. Like if you made that a decimal and a percent, it's probably less than 1. Yeah.
Do we have to do that?
You do not. You can leave it as a ratio.
So, we would have to reduce all the branches, right? If they could be reduced.
Correct. The ratios have to be reduced. All right, what is the probability of rolling, so you have a dice, a standard dice. What is the probability of rolling a 6? 1 out of 6. So you should know a dice has all numbers 1 through 6. And then rolling a 4. What's the probability of rolling a 4? 1/6, which is 1 out of 36. I almost wrote a 2.
You say it so nonchalantly, like.
I was starting to write a 2, and then I realized that was not right.
Flip the other way.
No, it's not. No, because I started here and was going to go this way, and then I added my, yeah. It happens. It's a 1. There you go. It does not look worse. No, it doesn't. Okay. If you draw 2 cards from a standard deck, what is the probability that you will choose a queen and then a 5 with replacement? So first of all, what is the probability that you will pull a queen? 4 out of 52, and I think it is easier to reduce from the beginning, so I'm going to start and reduce and make that 1 out of 13. And then pull a 5, and we replace that first card. So how many are in the deck still? 52. And I pulled a 5, so the probability of pulling a 5 is 4 out of 52, which is 1 out of 13. So 1 out of 169 is your probability. Questions on the front? Okay. What is the probability that you will choose a red king and then a 9 of hearts, knowing that the cards are red and the first card was replaced? So let's break this down. We're only drawing from red cards. How many cards are there? 26. So that's the deck that you have in your hand, is 26. So what's the probability of pulling a red king? 2 out of 26, or 1 out of 13. Okay? And a 9 of hearts, but we replaced that first card. So we still have 26 cards we're pulling from. How many 9 of hearts are in the deck? 1. That multiplies to 1 out of 338. Yes. Any questions on probability? Okay. Factorials. So you need to write this out. Yes, your calculator does all the hard work for you, but I want to see your work. So first of all, 12, 11, 10, 9, 8, 7, 6, 6. Because 5, 4, 3, 2, 1 cancels with that 5, 4, 3, 2, 1. So ignore that thing. I still need to write out my 4, 3, 2, 1. 4 times 3 is 12, so that's gone. 2 cancels with the 6, the 8, or the 10, it doesn't matter. So I have 11, 10, 9, 8, 7, and 3 to multiply, and I end up with 166,320. Okay. How many different permutations can be formed using the letters in the word Mississippi? So first things first is you have to know how many letters there are. How many letters are in Mississippi? 11. So on top is your total letters in the numerator. In the denominator are your repeats. So I see a repeat of I's, and there are 4 of those. I see a repeat of S's, and there are 4 of those. And I see 2 P's. Okay? So 11, 10, 9, 8, 7, 6, 5. 4, 3, 2, 1 cancels with one of them. I still have left 4, 3, 2, 1, and 2, 1. Right? How about 4 times 2 is 8, so that cancels. And 3 times 2 is 6, so that cancels. 11 times 10 times 9 times 7 times 5 is 34,650. Questions on factorials? Okay. So again, my recommendation for these is to plug it into your calculator once, write down your answer, then clear it and do it again. Use the following frequency table to answer the following questions. So we want to know, people were asked how many siblings they had. How many people were surveyed?
26.
How'd you get 26, Madison?
Add the frequencies up.
Okay, so you get the number of people surveyed from the frequencies. Now, before I find mean, median, mode, and range, I am going to write these out. So this table says that 3 people have 0 siblings. 7 people have 1 sibling. 9 people have 2 siblings. 6 people have 3 siblings, and 1 person has 4 siblings. Some of you don't need to write it out and can use the chart, and that's fine. Okay. What is the mean? Add them all up, and this is what I want to see on your test tomorrow. When you add them all up, you get 47.
Yeah.
And we're going to divide that by 26. So I want to see what you're plugging into your calculator. You should have gotten 1.8. Did you round? Maybe you didn't round. But that's why I want to, okay, so this is part of the reason I want to see what you're plugging into your calculator. So Jordan just said she got 1.7. So my guess, and I don't remember what it was that she didn't round. But if she's showing me this step, I'm not going to take off full points for 1.7. Okay, so if I can see what you're plugging in, and I know, okay, you plugged it in and you just messed up on rounding, then that's fine. Okay, what is the median? So for median, just start crossing out 1 from every side. I'm not going to do all of them because I already know the answer, which is 2. Remember, if you have 2 numbers that are the same, like there's no middle number, you have 2 numbers, they're even, you add them together and divide by 2, and that gives you your median. Your mean, median, and mode should all be numbers inside your data set. There shouldn't be any like crazy number to the outside. The mode is the number that appears the most often, which is 2. And my range deals with my siblings, so there are anywhere from 4 siblings to 0 siblings, which means your range is 4. Any questions on the probability test?
What's the median again?
The median is the middle number. So if you just cross off 1 on every side, like you just keep going forever. I don't even know where I'm at now. I'll just pretend I'm there. It's the number that's in the middle.
Where do I find the one for 2?
So if you have 2 numbers, you add them together and divide by 2. Anything else on your practice test? No? Okay.